I'm really excited about this video because Google wanted to sponsor a video talking about a security vulnerability that somebody found in one of their products. Think about this. They want to pay money so that I very publicly share Google had a security issue. That might sound crazy for most other companies, but we know Google has always had a great vulnerability rewards program. They've always been very open and inviting when it comes to bug bounty. But still, this kind of exposure to a much wider audience is an experiment. So yeah, they basically said to me, look, we connect you to some bug bounty hunter so they can tell you about a vulnerability they found and just make a LiveOverflow video like you always do. I couldn't imagine anything more perfect than this. They didn't give me any talking points. They didn't say what I can't say, just make a LiveOverflow video. All right then. So because of regulations, it says advertisement up there, but believe me, all they did was asking a couple of researchers if anybody would be up for making a video with me. And so here is Wouter, also known as WTM. He's from the Netherlands and is a full-time bug bounty hunter and spends a lot of time researching and finding bugs on Google products.
Basically, Eduardo got in touch with me and asked me to demonstrate a bug to you. I think it should give you an idea of what kind of bugs Google is looking for. And yeah, it also should provide some background information on how you can start finding bugs in Google products. Anyway, this is my approach. Other people might be doing it differently, but I will show you a bug and you can do with it what you want.
So the bug Wouter found was in the Google Cloud Console, specifically in the Cloud Shell. As you can see, this looks like a regular IDE, a text editor to write programs. But there's more to it, because when you look here at the bottom, you can see a shell. Here is how Google describes this app. Your Google curated admin machine. Google Cloud Shell provides you with command line access to your cloud resources directly from your browser. You can easily manage your projects and resources without having to install tools on your system. With Cloud Shell, the gcloud command line tool and other utilities you need are always available, up to date, and fully authenticated when you need them. While this sounds like a sales pitch for potential Google Cloud customers, it's equally a sales pitch for bug bounty hunters.
Everything you can do on the cloud platform, you can do from this box.
In other words, target me, I'm very critical. Find bugs here and it gives you lots of money.
I'm opening my project by default, but this can be any project. I can create a new project and open it the same way. And the only thing this does at the top is configure the gcloud client. So it's already configured and you can start working immediately. So let me show you. So now you see my session is configured for the dev shell project. And when I issue this command, you will see some instances I've created for this demo. So you can imagine if you can compromise or gain access to another user's Cloud Shell, it would mean you can get access to all resources of that user.
Awesome. I guess everybody understood the purpose of this web application. You can manage all your cloud services, and because of that, it's very critical. So it's a great target to hunt for bugs. But it's also a complex system, which means you first have to get familiar with it. And one particular feature seemed intriguing.
If you look at the documentation, you can see Google is stimulating people to open GitHub repositories into the Cloud Shell because it's a place meant for development. You can see they provide you with an API. You can create buttons in your GitHub repo like this with Markdown. So what this basically does is you open the Cloud Shell URL and then you pass in the GitHub parameter. And when you open this URL, it will download code from GitHub. It will do a git clone. And it will appear on this side. I will show you with a repository I've prepared for this. If you click on this button, you will see it switches over to Cloud Shell, and it will ask me if I want to clone this stuff into my shell. There's nothing special about it. It's just a git clone. So I assume it's safe, and I clone this. Okay, here you can see it starting to clone, and that's basically the README from my GitHub repository.
Why is this feature so intriguing? He looks at it this way.
So my initial thought was you can easily download content into your home folder on the Cloud Shell. That's what it's meant for. You download GitHub content into the Cloud Shell. But is this content really safe?
Okay, that's a great research question, right? That's a good direction to look for. But how do you figure out if downloaded content can do anything bad?
You have to be sure that no other processes are interfering with the content we've just downloaded. So I started looking into the inner workings of the Cloud Shell to see if any other processes are looking at the contents I run in my home directory to see if there are some vulnerabilities there.
That makes sense. You downloaded files into your home directory, but it's just a Git clone. So in order for something bad to happen, you either find a bug in Git clone itself, or something else has to access the files and do something bad. And something else is, of course, another process. So he had to figure out if some process reacts to the files being downloaded, which means he has to dig into the inner workings.
Now let me show you a bit about the shell itself. If you look at the processes running inside, you can see there's not much going on, because what I was expecting at first when I saw this, I was expecting to see some IDE-related processes. As you can see, there are no IDE-related processes here. So this must be a containerized application. So I wanted to start finding bugs in the IDE. It's called Theia, by the way, the IDE. It's open source. You can download it to play with it. There's a lot of stuff going on, but you only can see part of it. So you only see the SSH connections coming in, and you see some scripts used for monitoring to make sure Google knows you're alive. But other than that, there's not much going on inside your shell itself.
Looking for bugs in this open source project Theia makes sense. You could, for example, look for XSS issues triggered by files that you open in it, or maybe the Markdown rendering has bugs. But he was wondering why you can't see the Theia IDE when looking at the processes. This means the shell and the IDE run in different parts.
One thing that I noticed is that there are 2 Docker sockets available. This one is the default Docker socket, and as we check this socket out, we can see there are no containers running. So this in fact is a Docker inside Docker. My container, my Cloud Shell, is running inside a Docker container, but within that Docker container we also have a Docker socket. But the one that's really interesting, I thought, was this one. That's as you can see in the path name, it's a Docker socket running on the host. And that in itself is not a security vulnerability, but it allows you to escape from this containerized environment, since we are allowed to connect to the host itself.
Wait, what? Escaping the container is not a vulnerability? Let's check out the Docker documentation. So Docker works essentially by having a Docker daemon process which waits for commands by a Docker client. So the Docker command line tool simply interacts with the daemon via a socket, and you can say, please stop this container. Throughout the Docker documentation, you can find several traces about what that means. By default, a Unix domain socket is created at var run docker.soc, requiring either root permission or Docker group membership. So there's a file that is a so-called Unix socket, and it basically can be used to talk to the daemon. And only root can talk to it, or any user in the Docker group. And on another article, there is a big warning about this. Warning: the Docker group grants privileges equivalent to root user. For details on how this impacts security in your system, see Docker daemon attack surface. And on there, they write, only trusted users should be allowed to control your Docker daemon. Docker uses a Unix socket. You can then use traditional Unix permission checks to limit access to the control socket. And the reason why it's so critical is because containers are not really isolated like a VM from the system. If you can create arbitrary containers, you can just mount anything into a container, so you just gain access to the whole host system. That's why access to the socket is like giving somebody access to root. So yeah, why is this not a vulnerability here? And I think this is a great lesson. Context matters. Yes, you can escape that one container, but is the host system here really critical?
Some people would consider this a vulnerability, but I know people at Google do not consider this a vulnerability, because it all depends on what you're doing on the host. If the host itself is not containing sensitive information, it's not a problem. You look around at the host and see what's underneath.
And funnily enough, sometime later, somebody else shared this finding on Twitter. One-liner Docker escape from Google Cloud Platform's Cloud Shell to the host OS. And they added, reported to Google, and it was determined to not be a security risk. So always keep that in mind. Every target might have a different threat model, and sometimes it can be very weird. I made a video once about a few interesting edge cases for vulnerabilities. I'll link it up there in case you are interested in seeing some discussion about it. But anyway, let's see how the escape works and what insight it gives us. You can see here that Wouter executes Docker but specify a different socket. Not the default socket of the Docker daemon inside the container, but the socket from the underlying host, the host's Docker daemon.
Secondly, we start that container and we give it some extra privileges. So we mount a proc file system, the sys, and the root folder of the host. And then we attached host-based networking. As you can see at the moment, we don't have the host-based networking available. These are internal IPs reserved for container networking. And then we give it all privileges and all capabilities. And then we start it and execute a shell. And as you can see, this allows us to look a bit deeper into the internals of what Google is actually doing. Over here you saw we've mounted the root fs inside the LiveOverflow container, and I will just change the root into that. So we're now still inside the container, but this container has a lot more privileges. And as you can see, when we now list the containers inside, you suddenly see what's underneath the surface. And I will not go into the details of all these containers, but it should provide other researchers with a way to get started on Cloud Shell or perhaps other Google products, because I've noticed other Google services are having similar architecture. So now the two most important containers are this one. This is our shell, and this is Theia. It's the editor we see at the top.
Awesome. Now we really get some deep insight into the environment. And that's also where he spent a lot of time on. For example, he tried to visualize all the different containers and how they interact with each other.
Yeah, it takes a bit of time. And of course, this is not the entire picture, because this is just what I'm seeing. And I'm obviously not sure if there are mistakes in my overview, but it works for me. So according to this overview, I managed to find a few bugs. And if I find new information, I will add it here.
In case you wonder how exactly Wouter figured that out, it basically just comes down to having a good, broad understanding how software is built and how you can debug stuff. Let's do an example investigation. Here he used his new privilege container to get into the Theia container, the IDE.
And as you can see, it's a stripped down container, so you will have to install some additional software to start debugging.
So he installs procps and strace. Procps package contains tools like ps, so you can list processes, and strace can be used to trace system calls. I have used it many times before on this channel. It's a great dynamic debugging tool. But he has a problem, because this container runs without the capabilities to use strace. Or to be more precise, the container is not allowed to use the syscalls that strace would want to use for tracing. But from understanding the architecture of the system, he found out how to modify this container. It's actually orchestrated by Kubernetes, and so he knows how Kubernetes works and simply modifies the Kubernetes config YAML file and adds those security capabilities to this container.
Cloud Shell will reboot, and that's because kubelet picks up the changes and wants to make sure the pod keeps running in the state as described in the YAML file.
I was actually surprised that with these container changes, the website just refreshes and reconnects to the IDE again.
Yeah, it surprised me too, but it took a few tries, because I think I've lost the connection like 50 times or so, and then you have to wait and reboot the machine. But now it works, and I've posted this on GitHub, so everyone can download it and give it a try if they like.
When telling you the story of how he did this research, it sounds always so easy and straightforward. But I hope this comment by him gives you some insight how frustrating, slow, and tedious this kind of research actually is. We are just summarizing into a few minutes, probably hundreds of hours of work.
So now we can enter the Theia container again to start debugging some of its processes. Okay, now you see the main process of Theia, and we will be able to attach to it. We will write the output to a temporary file.
Then suddenly everything broke again.
It rebooted. Sorry. I don't know what happened.
I just wanted to keep that in because I need to keep reminding you, this is tedious, frustrating work. Annoying stuff like this always happens. In a video it can look smooth, but real life is not. Anyway, let's fast forward to tracing the Theia main process.
This is set up, and now I will connect strace to the SSH daemon on the shell environment. Okay, now let's say we create a new folder, Java code. Okay, as you can see now, some processes are running. I will close strace and see what happened. This is the Theia container, the IDE container, and it's connecting to our actual Cloud Shell to start, basically this jar. On this end, we will see the same system calls. Here we will see the Java is firing up the language server. But what I'm interested in is the behavior of the language server itself.
Okay, now you saw one example how he is able to trace and see what is happening. And he found out that when creating a Java project, it starts this Java language server by using SSH to connect to this jar on the other machine. There are language servers for any programming language. Such a program is used by something like this editor to provide information for autocompletion. It can check for syntax errors or can also help with syntax highlighting. And so here he discovers an attack surface with the language servers.
This file I've just created, but this can be any file I've just cloned from GitHub. So it's important that anything cloned from GitHub is secure and that the language server is treating it the way it should.
If he can find an issue with the language server that is started when you open a certain file, maybe that could be an issue. And that's what he found.
So this is just a regular repository. We have a Java file we are trying to compile. No, we're not trying to compile it, but it's happening anyway. Let's see what happens. Okay, it's in Dutch, but it asks us to, are you sure you want to clone this repository? Yes, we want. Okay, you see the new directory popping up. My repository is being cloned. Yeah, the language server is being fired up. And inside this workspace, I created a build.cradle file. And as you can see inside this cradle file, it just happened. Our code was executed.
And this is the vulnerability. Wouter found out that for whatever reason, the Java language server just automatically starts compiling any Java project. And Gradle build files allow you to specify shell scripts to execute during compilation. So without the user hitting build or execute a file, it just did it in the background. And as we mentioned in the beginning of the video, anything running in the shell can access all your other cloud stuff. So this is kind of bad. But here you can also see a very specific security boundary that Google has defined. It should be safe to clone any repository. Of course, if you clone an evil script and actively execute it yourself, that's your own fault. But a user does not expect a git clone to lead to arbitrary code execution. And Google didn't know about this behavior either. This was not intended, and that's why this is a vulnerability. And I know you're curious. He got $5,000 for this. That was really interesting. I personally learned a lot from this. At the end of our conversation, I had the chance to ask him a few questions and got some great responses I wanted to share with you. Do you report every small, odd thing you see because it could be a vulnerability?
No, I try not to send in everything. I believe my acceptance ratio is somewhere around 97% because you don't want to be wasting Google's time. These are highly skilled and expensive engineers, so you should think about everything you send in twice before you send it in. Sorry, you don't want to put them into the position where they need to decide on the quality of the bug you send in. In most of the case, you just need to send in quality and wait what happens.
How much time do you think you spent on researching new targets and how something works versus actually looking for bugs?
70% of my time just doing reconnaissance and finding something that's interesting enough to give a closer look at. But when you find something as, for example, like this target, then things start to shift and suddenly you can spend 100% of your time looking into these bugs. But overall, I would say 70% of my time is spent in just finding the next thing to look at.
Did you have any notable dead ends when looking into this target?
That's hard to say. I wouldn't have one specific dead end in mind, but of course, when you're doing bug hunting, you have dead ends every day because you have an idea, you try it out, and 9 out of the 10 times they don't work the way you thought they were working. So I would say dead ends are just, daily business to me.
I hope you enjoyed this deep dive into the bug hunting process. Maybe it even inspired you to head out now and research an application and possibly even find some bugs. I have linked some resources about this bug in the description. Check out the Google Vulnerability Rewards program, and please let me know, isn't this kind of sponsored video the best match that could ever happen for this type of video? What do you think about it? So thanks Google for supporting this video.